So first we begin by asking the question why and what is a diode? So that's what we want to know. I just punched that answer into Google now and let's see what it comes up with. So I typed diode and this is what it's telling me. It's telling me it's a two-terminal semiconductor device that allows current to pass through one direction. So they're telling me that it's allowing current to pass through one direction. So are they trying to hint that current is able to change direction and there is forms of current that can change its polarity or direction? Well, the answer is yes, because we have two forms of current, right? That's AC and DC. So here you are, AC, DC. Yeah, this is the band logo, that if you recall. So the link for this article has been provided in the description. You can go through it. And you have two forms of current basically, alternating current and direct current. Alternating current will keep changing its direction with every cycle. Direct current won't do that. So these are like really nice videos that explain how an alternating current is generated. This is a water analogy that shows even though how the direction seems to be changing, the resistor is still resisting the flow of its current, right? So that's a nice GIF that helps you visualize it. And you have a AC wave, sine wave form here, given a nice graph. And interestingly though, they've also mentioned that you have square wave and triangle waves that are also used in AC current and its applications. So once you're done with that, they even have given you an equation that basically governs these waves. And most of this is not necessary. All you have to know is that AC is something that changes current and reverses its changes its direction every cycle. Some of the applications for AC current is given. And DC current. DC current, again, I think this height is meant to represent the voltage. So direct current has no change in direction, it's just flowing through. So as expected, there is no changing in direction, it's just a steady voltage that's going along. So applications for the direct current is also given. So now you understood there are two forms of current, AC and DC, right? And both have its applications and advantages and disadvantages. But now comes the interesting part. So initially in the 1800s, when they were trying to decide which technology to employ, should we go with alternating current or direct current? That was the debate of the era. So then we had an industry pioneer, and if you recognize this guy, yes, this is Alva Edison, the bulb guy who invented the bulb and the telegraph and so many things. So this guy was all for DC because most of this machinery and everything that he could build, and he was also capable of building stations that support DC. So he did a lot of dirty lobbying and landering just to push his DC theory forward, despite its after effects and the disadvantages that were so obvious. But here we have our hero, AC guy. This is Nikola Tesla. He had some patents that for a generator that would generate AC current. This guy bought them, and then after a lot of legal struggle and battles, they finally won because the result is you see AC current being delivered to your house. So yeah, this article beautifully explains what happened, the story of it, and finally they selected. You can go through that in leisure. So this is how the first plant that looks like that had was running on AC current, and finally you understand that AC won the battle. So why AC over DC? I found this really nice Quora thread. So that answers this exact question. Why do we use AC supply in our homes? So the first two answers, if you read, I think that will be sufficient. The basic essence of that is you have two equations that govern the power generated when you're trying to transmit electricity from the generating station to your house. So you have L is equal to I square R and P is equal to VI. So the idea is to, one second. Yeah, so the idea is to increase voltage as much as possible in this equation so that the current is reduced a lot. So if the current is reduced, here it's a square term, right? The power dissipated is much less. So for very high voltages, it is possible to have very low current, and the power that is dissipated and the heat and all the energy that is lost is much, much less, and it can be transmitted for longer longer distances. So AC allows the voltage to be increased a lot with very minimal equipment and effort. So now there might be efficient ways to convert DC and all that, but back then in the 18th century, AC was the perfect logical choice. So yeah, these two answers will give you the disadvantages, advantages, and all that. Go through that in detail, and that basically answers the question of the problem they were facing. The problem they were facing is how to transmit electricity over long distances. And yeah, so they settled upon using AC current, mainly because it was so flexible in terms of voltage and reducing the power. Once they've settled upon AC, there is still a question to be answered. See, AC is like this, it keeps changing its polarity, right? But what about all the devices that you use in your house? They require DC current. Here you see, in the application section they have mentioned that all the TVs, the fridge, microwave, everything that you see around in your house have this tiny internal circuitry inside them. You've seen those circuit boards and things like that, right? So all of them run on direct current, not alternating current. So they require DC current. Now you can understand the problem I've been hinting at. The AC current that reaches your house from the generating station has to be converted to DC current so that all your itty bitty devices they can run on it. That is the problem they are trying to solve. And now it's your task to think about it. If you have a device that's uh, gonna allow current to flow in only one direction, so they basically invented a device that's going to make current flow in one direction. What's happening in the case of AC? Let's take a look. As we saw here, even in this wonderful water analogy, it keeps changing direction every half a cycle, right? So it's in one direction now and in the other direction second. You want this sine wave to resemble this one as much as possible. So how do you think we'll be able to achieve that? Can we stop the AC current from changing its direction every half a cycle? So let's say I block this somehow, like I place something here in a circuit, do something, stop this, so that let me just block it 1 second. So yeah, let's just try to forget what's below this, okay? So if you can imagine just this, just this, just this, we've managed to block effectively one half of the cycle. So that way you have current in one direction only. It's all a bit bumpy and loopy right now, but still it's a lot better than having it change direction, right? So do you think you can use this particular device? 1 second. Do you think you can use this particular device and come up with a circuit or something that allows current to flow in only one direction, right? Try to think about that, and in the next video we'll see how this was achieved.